Imagine that only one aircraft carrier is enough to completely change the military strength in any part of the world. These giant floating castles are not just moving air bases in open waters. They are symbols of a country's strong desire and great building power. Yet, building, caring for, and running these steel bases is a huge building and planning puzzle. One that only a few countries in the world have the power to do. Today, we take a close look at the different types of aircraft carriers around the world. How can you send a heavy fighter jet into the air from flight deck of just 200 to 300 meters? Engineers must do something that seems almost impossible to solve this. Regular airports on land need runways of at least 1,500 to 3,000 meters. But on an aircraft carrier, jets must reach takeoff speed on less than 100 meters. To solve this problem, there are two completely different ways of building in the world. Active slingshot launch tools or catapults and simple ski jump ramps. The French carrier Charles de Gaulle and giant American carriers rely on the catapult design, which means slingshot launch and wire stopping landing, using two 75-meter steam catapults. Charles de Gaulle launches his Rafale M jets into the sky in just a few seconds. But the newest and most exciting technology in the world is the electromagnetic aircraft launch system. Until recently, this highly complex system was only found on the US Navy's class of Gerald Ford supercarriers. Today, however, China has entered this special group with its newest carrier, the Fujian. Weighing over 80,000 tons, Fujian is the largest and most advanced carrier built outside the United States, using magnet-powered launchers to send next-generation J-35 stealth fighters into the air. In contrast, carriers like India's INS Vikrant and the UK's Queen Elizabeth class work without catapult slingshots. INS Vikrant, India's first carrier, built in its own country, uses a starboard design. Its MiG-29K jets launch by running up a 14-degree ski jump ramp. The United Kingdom also chose a ski jump ramp for its Queen Elizabeth class, although the British government briefly thought about changing the second carrier, HMS Prince of Wales, to use catapults slingshots. The very high cost estimates made them go back to the original design. These carriers now carry F-35B Lightning stealth jets, which can take off in short distances and land straight down like a helicopter launching from a 12-degree ski jump. Sometimes changes in world politics and trade bans alter the path of new ideas. The Turkish Navy's flagship TGC Anadolu is a perfect example of this. At first, it was designed to carry F-35B jets, but Turkey was removed from the program after buying missile system from Russia. In response, Turkish engineers changed the ship's rule, turning TGC Anadolu into the world's first flight deck-based carrier, made especially for flying drones. Its deck is now set up to run special homemade drones like the folding wing Bayraktar TB3 and the jet-powered stealthy Bayraktar Kızılelma, which can land on the short deck without stopping cables. In 2026, during a NATO exercise, TGC Anadolu showed this skill, successfully running operations combining human pilots and drones in the Baltic Sea. Meanwhile, Brazil chose a different plan by buying an old British helicopter carrier and naming it NAM Atlantico, made to carry a large group of helicopters such as the EC-725 Caracal and 70B Seahawk. As well as long-flying search drones Atlantico allows Brazil to show its military power across its waters at a much lower cost than a standard aircraft carrier. The engine system of a carrier decides how long it can stay out and how far it can travel. Advanced carriers like American Ford class and France's Charles de Gaulle are nuclear powered by two nuclear engines. Charles de Gaulle can sail for 20 to 25 years without needing new fuel, limited only by the food left for its crew. Similarly, the A1B reactors on the Ford class make 3 times more power than older carriers, providing the huge power needed to run magnet catapults and future laser weapons. Other countries have chosen regular engines. The British Queen Elizabeth class is powered by giant Rolls-Royce Marine Trench MT-30 gas engines, while India's INS Vikrant uses Ford General Electric LM-2500 gas engines. On the other end of the list is Russia's only carrier, the Admiral Kuznetsov. Unlike Western ships using gas engines or nuclear power, Kuznetsov runs a Mazet, a very thick, heavy oil. Below the flight deck lies another amazing world, a city that takes care of itself. India's INS Vikrant, measuring 262 meters in length, has 2,300 separate rooms run by a crew of 1,070 sailors. The ship has a complete hospital area, special rooms for female officer, and 8 kilometers of hallways. On board the British HMS Queen Elizabeth, 4 giant kitchens are run by 67 cooking staff, with the largest dining hall able to serve 960 meals in just 1 hour. Its medical area has an 8-bed ward, an operating room, and a dental clinic. Meanwhile, new automated systems on the US Navy's Gerald Ford have allowed it to run with about 700 fewer sailors than older ships. This smaller crew size has freed up space, allowing for quieter man-sleeping areas, vacuum toilets for both men and women, and special Wi-Fi rooms where sailors can talk with their families. Aircraft carriers are the best tools for showing military power around the world. In November 2001, France sent Charles de Gaulle to Indian Ocean to help in the war in Afghanistan, sending planes to fly hundreds of missions. In 2011, she returned to stop planes from flying under UN rules over Libya. In April 2025, during high-stakes tensions with Pakistan, India quickly sent its new INS Vikrant alongside a group of 36 warships to the Arabian Sea, making the other army's ships and planes stay on defense. Yet, the symbols of power are also very expensive and easy to hit targets on the water. Building INS Vikrant cost about $3.1 billion. The Queen Elizabeth class cost $7.6 billion for 2 ships, and the USS Gerald Ford cost a giant $30 billion. With so much money and so many human lives on the line, technical failures can be terrible. Russia's Admiral Kuznetsov has been out of work since 2017. In 2018, its floating dock sank, causing a 70-ton crane to crash into the flight deck and leaving a giant hole. Fires in 2019 and 2022 caused millions in damages, leading to its crew being sent to fight on the ground in Ukraine. In August 2022, the UK's HMS Prince of Wales suffered a broken propeller part shortly after setting sail, requiring a 9-month repair. The US Austral Fort has faced constant toilets and PIP problems. Flushing the system with the special chemicals cost the Navy $400,000 each time. For Spain's John Carlos, the decision not to buy the F-35B means that once its Harrier jets get too old, its jet's operation will end completely around 2030. Despite the giant cost, technical risks, and the growing danger of fast missiles and quiet submarines, the world's leading countries show no signs of stopping their work on aircraft carriers. While some Navy experts say that traditional carriers are too expensive and not useful in modern wars, arguing that robot systems and drones are the future, the world game tells a different story. China is already designing its next generation Type 004 carrier. The UK is testing drone flights on its active carriers. India is actively running 2 carriers at once, and the United States countries its long-term plan to build more Ford-class supercarriers. In world politics, nothing shows a country's strength and will quite like the giant shape of a steel base on the ocean. Despite these weaknesses, aircraft carriers remain the unlimited leaders of engineering, planning, and power at sea. Iron giants whose control over the world oceans is set to last for many years to come.